right, welcome everyone. Thank you for joining us for this edition of Production Ready Containers. My name is Dan Garfield. I work for CodeFresh, and we kind of sponsor and run the Production Ready Containers Meetup. Today, for you, the persistent, those who love containers, we have a gift of a Raspberry Pi. How many people already own a Raspberry Pi? You're disqualified. I'm just kidding. I couldn't snapshot you that quick. But we'll do that at the end, and we'll give away the Pi to basically anybody that registered. WSO people are welcome to enter as well. You just need to sign in at the back. So with that, today I'm really interested in today's talk because it's what's called cloud native programming with Ballerina. And what really interested me, I first saw Ballerina at KubeCon Europe, and I had never heard of them before. I walked in, and they had this ginormous booth, and I was like, who the heck is Ballerina? What is this thing? And they're like, oh, it's a cloud native programming language. I was like, that doesn't just sprout out of the ground, wholesale. This is crazy. And so as I dug into it and started talking with them, what I thought was really interesting about it was that they had this approach to sort of, I want to call it almost like full stack engineering, where instead of a lot of people are like, oh, it's like your infrastructure as code. But with Ballerina, it literally is your infrastructure is in the code with all of your code. It's all tied together. So I thought it was just really interesting. And so we talked about potentially doing a meetup together. And it turns out, even though I met them in KubeCon Europe, their headquarters, well, I don't know if it's your headquarters, but your Ballerina office is essentially less than a half a mile away from CodeFresh headquarters, which is just down Castro. So it was like, wow, we had to go to Europe to find somebody a block away from us. But here we are, and so I'm really excited. Kasun's going to be speaking. And just some announcements before we jump into it. We do quite a few events, and a lot of things we do our meetups, a lot of things we do our webinars. If you go to codefresh.io/events, you can basically figure out all the stuff that we participate in. Just a note on tonight's meetup, it is being broadcast. It is on Facebook right now. So if you come by this microphone, be aware that your conversation is hot. And so don't say anything that you don't mind Facebook and a few million of your closest friends knowing. Upcoming tomorrow, we're doing a webinar that's called Skip Staging, Test Docker, Helm, and Kubernetes Apps Like a Pro with Sauce Labs. And we're putting that on with Sauce Labs. And we'll be basically demoing how you can approach, how you can leverage Kubernetes to create short-lived environments to test. So you're not stuck with a staging server. So that'll be interesting. And then coming up, next week, we're doing a webinar on blue-green deployments with Kubernetes. If you missed it, we recently did a webinar on Canary deployment with Helm, Istio, and CodeFresh, which was pretty cool. There's a lot of, it's actually the best demo I've ever done. Really, really love it. I can't speak highly enough of that thing that I did. So I hope you'll like it as well. But there's just tons of stuff on there. So please go take a look, bookmark it, subscribe to our blog, and you'll see these events as we do them. And we always post recordings. We always post slides. We'll try to do the same thing tonight, and we'll get the announcement out on the meetup. Last question. How many people is it your first time at this meetup, at the Production Ready Containers meetup? Wow, like most of the people. So hopefully what you see tonight, you'll say, those Production Ready Containers meetup folks sure know what they're doing. We're going to come back in the future. We're going to tell our friends, and we really appreciate that when you do and you leave a nice review on meetup.com. That helps more people discover what we're doing here. So with that, Kasun, why don't you come up and maybe introduce yourself and get started. Just give them a round of applause. Thanks.
Okay, thanks, Dan. Thanks a lot, everyone, for coming. So in today's talk, I'll be talking about cloud native programming in practice. So in the process, I'll be touching upon some of the technologies such as Ballerina, as Dan mentioned, and also some other technologies that helps you to build cloud native applications. brief introduction about myself. I've been working for WSO2 as the Director of Integration Architecture. So WSO2, some of you may have heard about WSO2. It's an open source middleware company. So we provide open source solutions on integration, API management, and identity and access management domains. So we are also working on this new programming language, Ballerina, which is targeting building cloud native applications and microservices. This is a quick overview on today's session. So we are going to define what cloud native is and what is meant from a cloud native application. And also, as technologies to build cloud native applications, we'll talk about Ballerina, Metaparticle, and CodeFresh. Yep.
Speak up a little bit or maybe turn the mic up. Thank you.
Yep, thanks. Okay, so let's start with what is cloud native. Any thoughts on what is cloud native? What is a cloud native application? If I had a look at what is a cloud native application, so it definition says it's a methodology for building and running application that fully exploits the power of cloud computing. It's a very abstract definition, right? Yep.
So what is the power of cloud computing?
Yes. So that's why I said it's abstract. So then I had a look at the characteristics of cloud native applications. So with that, we can identify some of the important aspects of cloud native applications. So there are 4 main characteristics. The first one is that given cloud native application is built, is composed of a microservice or serverless function. So that means when you are building a cloud native application, you build it as set of microservices or set of serverless functions. So that means each functionality that you are building is built as a microservice. And also these applications must be packaged into containers, which means you'll be leveraging Docker and also Kubernetes as the Docker and the cluster management tool. And also cloud native application runs on continuous delivery model, which means as soon as you have some features ready, you should be able to deliver it directly into the production state through the development pipeline. And also these cloud native applications are managed dynamically in the cloud. That means you deploy an application and then you manage it as part of your cloud. That means all the auto scaling, observability, monitoring, logs, tracing is also part of that managing dynamic aspect. So any application that has these characteristics can be categorized as a cloud native application, right? So if you look at the technologies that are available for building these cloud native applications, so we have this term called cloud native programming. So actually this, all these quotes are from Brendan Burns, who's the co-founder of Kubernetes, and also he's the founder of Metaparticle. So when we are building cloud native applications that has all these characteristics, the programming language that we are using. So what we normally do is we write code and then we use some set of descriptors or some set of YAML files to compose some kind of application and deploy that into your server. So basically, at the time of the coding, you are not really aware of what kind of deployment that you have and what kind of environment that you are going to deploy. And also, so what Brendan suggests is that so what Brendan suggests is that we should build as part of the coding, as part of the languages that we are using, we should have some of these cloud native characteristics inbuilt. So for example, when you are building, let's say you are building a service, right? Microservice, say Spring Boot or any other language, any other framework, then you should have some set of abstractions to make it deployable into a container, or make it deployable into AWS or any other cloud provider. I'm not saying you should couple it, but there should be some abstractions or extensions to make your job easier. So now if you look at the current technologies that we have for building cloud native applications, there are like a disparate set of technologies, right? So you have, so again, starting up with, you start with the service, then you create some descriptor files, then maybe some other descriptor to define your build pipeline, development, QA, testing, production. So likewise, there are disparate set of tools. So Ballerina is a language that we have been developed from scratch to address some of these concerns when it comes to cloud native application development. So it's a cloud native programming language. It's a fully fledged programming language, which is designed for serve a very specific purpose, right? As you know, there are so many languages out there. So why, you may be wondering, why yet another programming language? So if you look at now, when we were discussing about the characteristics of cloud native applications, we had quite a lot of services that we have to deal with, right? You have a lot of microservices which are fine-grained, and what we are seeing in the modern enterprise architecture is you are seeing a huge increase of these microservices and serverless functions, so that when you are building application, you have to talk to multiple other applications. So you may be talking to other web APIs, data, databases, or any other SaaS applications, and also any other legacy applications. So therefore, building a cloud native application that talks to multiple other systems is a challenge. And a development of a cloud native application means you are basically plumbing various other endpoints, right? You are talking to multiple other applications, and as part of your application, there are some features that you have to build from scratch. So for example, things like circuit breaking, as well as content, the routing logics, and how to handle security, how to handle events, and how to handle resilient communication, because you're basically invoking all these endpoints over the network, right? Network is not network. You need to make a resilient network call from one cloud application to the other. So Ballerina is an effort to make your cloud native application development easier. And if you look at the existing technologies that we have to build this kind of integrations, so in one extreme of the spectrum, we have conventional integration solutions. If you are familiar with service-oriented architecture, we have enterprise service bus, enterprise application integration, and BPMN solutions. So these are not agile. These are like monolithic solutions that are built with legacy technologies, and mostly they are configuration language driven. You have to have some kind of a domain-specific language to configure a given product. And on the other side of the spectrum, we have general-purpose languages like Java, Go, and other frameworks like Spring. And the problem with these languages is they are not integration simple. That means you really don't have the necessary abstractions to make the integration of those applications easier. So Ballerina is an effort to fill this gap by providing all the high-level abstractions that are necessary to build integrations. So as I said earlier, it's a compiled, type-safe, and concurrent programming language. And these are some of the key design principles of the language. So as I said earlier, integration is now done with coding and not using configuration like conventional ESP solutions. Therefore, we promote the code approach, and we have the textual and graphical representation of any integration scenario. So that means you can develop your integration using code, and also you can graphically see how interaction happens between applications. So during the demo, we'll go into the details. And also we don't hide the network at the language level. That means we have all the network related abstractions such as protocol representation, protocol network aware data types as part of the language. And also by design, we enforce using best practices so that you don't have to run a specific, explicit debugging tool or like a find bug kind of a tool to detect any issues with your code. And likewise, there are things such as making your program secure by default, again enforcing security related features, as well as making your network calls resilient by providing things such as circuit breaking, load balancing, fail fast kind of patterns out of the box as inbuilt features of the language. Okay, so without going into any other detail, I'll quickly walk you through a simple demo of Ballerina and how you can build a simple network aware service using Ballerina. So if you go to ballerina.io, you can, so Ballerina language is fully open source, 100% open source language. So it's under Apache license too. You can download, and we have like quite a lot of examples on Ballerina, Ballerina by examples and Ballerina by guides. So you can simply go to the download page and download the Ballerina, and I have already installed Ballerina in my machine. So let's get started, and it has plugins for various IDEs. So I'm currently using the VS Code editor, and we also have plugins for IntelliJ IDEA and Atom, and also we have a Composer, which is a web-based editing tool. So let's suppose we need to create a simple HTTP service that accepts a request and basically do a simple hello world kind of a service. So so let me, so I'm using my IDE. I think you guys, font size, yeah. So let me create a service. Can you see? Yeah. Okay, so now let me start it again. So I can start with, so now you can see we have an abstraction called service. So I just simply create a service, and since I'm going to use HTTP, I'm going to import HTTP package into my program, and then I can name my service as hello and resource as hi. And now this is a service that defines, maybe I'll make it
bigger.
Can you zoom in at all?
Yeah.
You can move that zoom bar.
So now I have a service skeleton defined, and now I can basically create a response that is again from HTTP. Let's name it response. Okay, and then I can set some payload. Yeah. This one? Yeah, this looks better. Yeah. Okay, so I'm about to set a payload. Let's set hello world. Okay. And now I have a response. I need to send it back to the client. So, so Ballerina has now I defined the concept of a service, and it has also a concept of a endpoint. Endpoint can be it can be an external endpoint that my service is talking to, or it can be an inbound channel to my service. So in this case, I'm using HTTP. Therefore, I am going to use endpoint as a listener, which is a HTTP listener. Then I have to define a port 9090. So this is my inbound HTTP channel, and from that I'm going to bind my service to that endpoint. Okay, so now I bind my service to that particular endpoint, and I have the response ready. So let's send it back to the client. So you can see there's another endpoint. So this is the inbound endpoint. This is the endpoint that represents the caller, the client who's calling me, right? So then, since I need to send it back to my client, I'm setting response. And also, all the errors are enforced. So actually, you need to either handle errors that is written from this particular invocation, or you can ignore it with this syntax. Because you need to be very explicit. You need to explicitly ignore the error. Okay, so I'll make it smaller. Yeah. Right. So now I am pretty much done with my service. I have a service endpoint, and I am sending back the response. So let's try running this service and invoking the service. Let's save it. I'm invoking. So by default, the service name and the resource becomes the context. So you can invoke the service with hello/hi. Okay. So I get the hello world back from the curl request. So this is a very simple HTTP service that I developed. Now let's have a look at like a more production or more real world service developed using Ballerina.
So let me take this particular service, which is having like a multiple other endpoints. So in this particular example, I'm doing, so basically I'm creating a service which talks to Twitter, as well as I'm talking to another service, the code service. So basically I have a service, I talk to Twitter, I talk to another code service to get the specific string code. And then I tweet with that code by invoking the Twitter API. So in order to understand this service, now this is the code that you have developed, that we have developed to develop the scenario, but you can see the graphical view simply by clicking the button on the right hand side. So basically this interaction diagram shows what's actually happening. So this is my service, this is my invoker, the caller. The caller is calling my service, and I'm invoking one particular service named port service, and I get the response, and I feed with that response by using the Twitter connector. So basically, if you look at the code, it's the same, it's a similar code that we have for our Hello World service, but we have more features here, such as now I have used context path, HTTP context. I have used base path for my service. And then as part of my resource definition, I have used path, and I have limit my incoming request to post. So it's similar to any JAX-RS service. And so when I have defined, so as you can see, for Twitter, we have a specific package that you can import. So I basically import Twitter package, and then I use the Twitter connector, which is a client connector that allows you to connect to Twitter. And then I configure all the credentials that are required to all the access tokens, which are coming from a separate file. So this is coming from a TOML file. So you can basically pass the TOML file when you are running the service. And also the other service that, so this is a dummy service that we have hosted, which is sort of an unstable service, right? So when you are invoking that kind of a service, you need to have some resiliency. So that's why we have used circuit breaking. So as you can see, as part of the language, we have circuit breaking built in. So if you are not familiar with circuit breaking, it's a mechanism to make your service calls resilient, so that if there are, like, say that you are invoking a particular backend service and you are getting failures, and you need to stop invoking the service if you encounter a given threshold of failure. So then you put a circuit breaker. So if something goes wrong, the circuit breaker goes to the open state, so that it will not invoke the backend service because it is already failing. And similarly, we have other resiliency patterns, such as retrying. You can retry a given request against a particular service. So, and also the timeout, how long it should wait for a response. So, so all those things are part of the language. So you don't have to specifically use any other external libraries to get the job done. And also another interesting feature is we have, now this is the invocation of the Twitter. So basically, I'm invoking the tweet operation of the Twitter endpoint. And also we have JSON as a built-in type of the language. So you don't have to use a specific parser for doing JSON validations or JSON data types. So again, from the diagram, you can understand what's actually going on. So it's provide a better, so, and with the web editor, you can either start from this side or this side, but in the VS Code, you can just visualize the interactions. But in the Ballerina composer, you can either start from the graphical editor or the code. Okay, now let's try running this program. So again, it's simple Ballerina run command, but I'm passing the TOML file instead.
file name is then my request is okay, it's smaller. Okay, so now I have my service up and running. So let's try to now, we need to send a post request for this particular service because I have like enforced post request only to this particular resource. Let me get the request. It's right here. Yeah, let me use the same request. So this is my post request. Okay, circuit directly goes into the open state, maybe because of an error that thrown from the, now you can see circuit is already in the crypt state, right? That we can try multiple times. It goes to the half open state. That means it tried once, but it failed. Yeah, maybe we can try again. Okay, now it seems like I got a response, right? So it's an intermittently failing service. I can go and check my Twitter. Whether I have posted anything. Yeah, so this is the one that I have posted. So this is actually getting something from Simpsons code service and posting on my timeline. Okay, so this is a simple like a actual real world Ballerina service built. So I'm not going into the details of Ballerina in this session, but you can have a look at ballerina.io. Any questions on Ballerina up to now? Yeah.
Couple of them, but something very specific was the endpoint logic that you write. Is that eventually running as part of the same binary which is running a service, or is that running on a genetic proxy with somewhere else?
It's part of the same binary, same runtime. So
and your language compiles down to binary or something.
So we have our own virtual machine implementation. So it's not a JVM language per se, but we have our own virtual machine implementation, and the compiler is currently built using Java. But I think we have some efforts going on to make it a LLVM based runtime. So and so let's move on to the cloud native aspect of the language. So now, so this language comes with other set of features. It's not just a language, but a whole ecosystem around the language. So as you have seen, we have editor plugins, IDE plugins, as well as a test framework, built-in test framework, which again I'll use as part of my later demo. And also we have extensions, deployment extensions for Kubernetes and Docker, so that as part of your service development, you can define whatever the Docker related annotations or Docker related attributes to generate your Docker image. So same applies for Kubernetes. So once you build a service, you can make your service observable. That means we have out of the box support for integrating with observability tools such as Jaeger, Zipkin, Grafana, etc.
And also we have our dependency management, versioning, and package management capability inbuilt. Unlike other languages, everything is built as part of the language. Like for example, Maven came after we built Java, right? But here we have everything as part of the entire ecosystem. And also we have Ballerina Central, which is which resembles to Maven Central, which is our package management repository. So since we are talking about cloud native and cloud native application development, I would like to quickly go through some of the Docker and Kubernetes capabilities. So let's start with another service. Suppose that I need to develop a service that that I need to deploy into Docker, right? So this is a simple hello world example. No any complicated code related to your integration logic, but so the same service that I developed, now I have annotated my service with Docker annotations. So these are compiler extensions. So during the build time, it actually, so I have imported the Ballerina X Docker package. Since I have annotated with Docker configuration, so it will actually build a Docker image once I build my service. So for example, let's try, let me, okay, I have one Docker image created. So let me build my Ballerina service using Ballerina build. So I'm basically building. So as part of the build process, now you can see it processes the annotations and it actually creates a Docker image. Now I can run, I can basically run my Docker image using this particular command. And also I can check, now it is created 20 seconds ago. This is my new Docker image. And also you have, you can extend this further into other annotations. For example, if suppose that you want to push this image into a particular repository, Docker, say Docker Hub, then you can annotate your service with your type name, username, which is taken from the environment, so that it will automatically push into your Docker repository. And when it comes to Kubernetes, we have similar set of annotations. Now this is the same hello world service. I have my Docker Edge running in my machine. Let's check whether I have any running ports now. And in this hello service, I have, again, similarly, I have imported Kubernetes package. Then I use the Kubernetes deployment. So this will basically create a Docker image first with this particular name. And then it will create a service, Kubernetes service. And I want to expose that service as a node port. So let's try building this service. Again, the same command, Ballerina build. Now you can see it generates Kubernetes deployment and also the Docker image. And now I can directly apply let me try it again. Yeah. Now it creates all the artifacts. I can directly apply kube control apply with this generated artifacts. It's reside in the same directory. I can Okay, so I directly apply to my Kubernetes. Now let me go and check whether it is there. Okay, now I have a new pod up and running. And let's try to invoke that. Now this is my node port, and this is my service. So I can invoke my service with, let me check. Yeah, this is the syntax. So okay, so this is my hello service, and I'm going to substitute my node port. All right, so okay, hello world from Kubernetes, and and also we have like I have shown a couple of attributes, but if you look at Kubernetes extension, it has various other Kubernetes attributes that you can use as part of your annotations. So as you can see, this makes your life much easier. So that is actually what Brendan talks about when you have all these things as part of your programming language to build cloud native applications. Right. Any questions on Docker and Kubernetes support?
So I have a question.
Yeah.
You might want to repeat it just for the live stream, but so they can hear it. When you build a Docker file normally, like if you're using like a node or something, oftentimes you don't necessarily get the same point dependencies and you don't know if they change.
Yeah.
Is there anything here that will help me lock down and make sure that I always get the same every time I build?
Are you referring to something like having environment specific details as part of your image?
Yeah, I guess I'm asking if every time I run this, as long as I don't change the code, am I guaranteed to get the exact same configuration, exact same Docker?
Yes, yes, yeah. So, so I think his question is on whether if you are building this multiple times, is there guarantee that you'll get the same image, image with the same attributes built, right? So it is guaranteed. And if you have any specific environment specific, because when you are building a Docker image, you may have to use some environment specific parameters. So those things again can be part of the language. As you have seen with the Twitter, we externally import some access tokens from external file, right? So similarly, you can have these values. For example, you can read these values from the environment variables directly. So you can configure based on your development deployment environment, you can fetch all those things as part of a environment specific parameters.
Another question, is there anything here to help you deal with like target different versions of the Kubernetes API when they just release 1.1? Maybe there's some specific stuff. Is there any way to set like an API version for the output?
I think we don't have it right now. We currently use the current stable version of Kubernetes. So I think, yeah, that is true because there are a lot of changes coming up in each of the new Kubernetes releases. So we probably need some kind of a way to specify like a tag or something, like a version parameter.
Are there any specific use cases that you guys have envisioned for Ballerina that you think are, obviously microservices, Kubernetes would be one, but are you envisioning most people using it for web server, like, you know, HTTP servers, or you know what I mean?
Yeah. So so if you take Ballerina, so it is designed for making integration easier, right? So it can be either HTTP or gRPC or the popular microservices protocols, but this can also be a asynchronous messaging integration based solution. So for example, suppose that you have some messages residing in Kafka and you need to send it to, say, maybe RabbitMQ or some other file system, then we have similar use cases built in. So for example, if you look at Ballerina guides, so there is a Kafka guide. So basically, similar to HTTP, Kafka is also becoming an inbound protocol, inbound function. So this is a Kafka consumer, again, which is an endpoint that can actually bind to a service. Basically, you can create a service which consumes messages from Kafka, as well as you can publish messages to a Kafka topic as well. So likewise, there are broad set of scenarios, and even we work closely with other things such as streams. For example, you get a continuous set of events in a stream, then you can define a stream QL kind of a query, and you can consume that stream as part of your service. And also we work with other solutions such as Stio. So this is how Ballerina can work inside Stio. Because of these annotations, integration with Stio is also quite straightforward, because you don't have to build any artifacts from the ground up. You can use the generated Kubernetes artifact and directly deploy that into Stio with few tweaks into your YAML files. Okay. Any other questions? Yeah.
So question around the compiler.
Yeah.
So this Ballerina compiler can produce Docker files, YAML files for Q and binary JVM code.
Yeah.
Can we probe into how it generates that and kind of tweak it after the fact? Or have you seen people wanting to do that?
Yeah, the Docker and Kubernetes are created as part of the compiler extensions. So the other things we can't control it. We can't basically generate any Java code or anything like that. But you can write your own extensions. Let's say you have a new container management system like Titus or something. So then you can write your own compiler extensions for Titus and then generate your own artifacts, but not the runtime code. Maybe Samira can. Yeah.
Yes. So the idea is when you have a compiler, so you will get all the events like this is function, the operations happening. You will get, if you register this plugin, you will get notifications. Based on that, you can generate YAML files and everything. I think that's what. Yeah.
Trying to figure out how to kind of figure out all these things. Related to that, like, since this is a whole new language, a whole bunch of packages which don't exist for it, right? So
Yeah.
Can you interrupt with any other language packages?
At the moment, no. So only the recommended way is to expose that functionality as a service and invoke that over the network.
Yeah. To add to that, we also have a Ballerina native interface.
Yeah.
And so sort of like a Java binding, but that's not usually the recommended approach. But you can also invoke Java APIs. But you have to have a Ballerina interface.
Yeah, so I think then I can move on to the next section along with the same question, because I know most of you are, I think all of you are not using Ballerina at the moment. So if you are using Java or any other languages, then how I can make my services cloud native, or how I can easily create my services deployable on Docker and Kubernetes. So to address that particular problem, we have something called Metaparticle. So this is not specific WSO or Ballerina, so this is a totally independent technology, but since it is related, I would like to talk about it. So Metaparticle is a standard library, again created by Brendan Burns for addressing most of the concerns that he mentioned. So it supports multiple languages, .NET, Java, Python, and Node. And it allows you can basically write your service using any of those languages and use Metaparticle standard library to deploy your service into Docker and Kubernetes. So I'm not going into the theory aspect of Metaparticle. Let's suppose we have a Spring Boot service, just a plain Spring Boot service, and I want to expose that directly into Docker and Kubernetes using Metaparticle. So I'll walk you through a simple example. Okay, so this is my Spring Boot example. So it's a simple single resource service, and to use that use Metaparticle, you simply have to import this packages, and similar to Ballerina, you can use similar set of annotations to make it. So the first one basically packages it, basically create the Docker image, and the runtime actually represents the Kubernetes. So it's directly couples to Kubernetes, and you can define how many replicas you want and what is the port that you are going to expose. So that's all you have to do. So you can just put all the annotations and then use this particular containerized, basically with the containerized flows against your Spring Boot application. So that's all you have to do. And similar technique can be applied across other languages, .NET, Python, and Node, I think. So let's try running this program. Just before that, I'll check my Kubernetes. I have one pod running. So I'm simply doing a Spring Boot run, just running it as part of the console. Yeah. So it's actually building the entire service, and after building the service, then it uses something called MP compiler, Metaparticle compiler, to talk to my Docker and Kubernetes runtimes, and then it deploys into Docker and Kubernetes. So after build success, now it starts preparing the Docker image. So it's running. So let me check my ports. Okay, I have my Metaparticle running. Let's try invoking. And also I can check my Spring Boot, Docker Hub, whether it has pushed. Okay, it's pushed a minute ago. And then I can do a simple curl. And also one thing to mention is, so unlike Ballerina, you don't really get any fine grained set of, in Ballerina, you can directly map it to your Kubernetes deployment, Kubernetes service, and Kubernetes ingress, right? Here you don't have, so this is a Ballerina Kubernetes notation. This is, you know that this is the Kubernetes deployment YAML. This is the Kubernetes service YAML. This is the Kubernetes ingress. But here it's not that transparent. So you need to translate these values to the Kubernetes terms. And also you can't define an ingress. So therefore I created the ingress manually. So basically it's going to exposed over Metaparticle path. and I can invoke. Okay, so this is a response from from the Metaparticle. So you can have a look at, and also there are like very limited set of features offered from Metaparticle at the moment. So, but I guess with Ballerina we covered the entire Docker and Kubernetes deployment spectrum. So you can basically try it out and do kind of a comparing and contrasting. And moving on to the final bit of our session, CodeFresh. So when you are building this kind of a cloud native application, you need to have a continuous delivery pipeline. So CodeFresh provides a continuous delivery platform so that you basically start with your repository, and then you define the pipeline, different stages of your CI/CD pipeline, and which ended up by deploying everything into your production servers. So it goes through different integration tests, performance tests, security tests, and there are different stages of the build. So it can, maybe Dan can add more information. I'll try to set up a simple Ballerina project and integrate that to CodeFresh, right? So, so this is my Ballerina project. Again, it's a simple service, and also I have used. I mentioned about Ballerina test capabilities, unit testing and integration tests. So by running Ballerina, basically I can run Ballerina test command to execute test on my my project. So this is again a simple hello world service. So I can basically point to a given package and run the test against that package. Skipping. Oh yeah, address already is, because I'm already running okay, so let me walk you through the build pipeline of CodeFresh so that you can understand what's actually going on. So as the first step, I added the Ballerina repository, which is actually coming from my GitHub. So this is my repository that I have added to CodeFresh. And then I define the build pipeline. If I go to build, I have a build pipeline. So different stages of the build. Actually, this is specified using a YAML file. And so by default, the Ballerina, the base image, I'm using a customized base image because of some permission issues. But apart from that, this is pretty straightforward. So I define a image as the Ballerina. So basically, this particular pipeline is doing. I have my hello world service. Then I build my service. Then I create a Docker image, and for that I use the generated Docker file. So when I do a Ballerina build, it actually generates a Docker file as well. So yeah, I'm pointing to that particular Kubernetes Docker. So this is generated, and this is my Docker file. And then I run unit test against my repository. So everything is specified using CodeFresh. And then I do a Ballerina test hello world service. So this is my testing phase. Finally, I'm deploying that into my Google Kubernetes engine cluster. And I have actually configured my Kubernetes, CodeFresh Kubernetes with my Google GK cluster. So yeah, so now what actually happens is when I do a simple change, like let's say I do a simple change to hello world with CodeFresh. And I'll update the test as well to avoid any test failures. Okay. Now I have updated my code as well as test. Now let me commit my changes. I'll go to the build section. There's no any build going on. Okay, I have committed and I have pushed my changes. Let's go to the report. Should trigger a new build. Okay, now there's a new build pending. So, and I can see the status of the build. Now it's building the image. Now it's running the tests. Tests are success. Now I'm deploying that into my Google Kubernetes cluster. Okay, it's completed. And I can go to my Kubernetes section and go to my service. Actually, I have been deploying it to my service. Okay, I have to invoke my service. I have to give hello and say hello. Okay, now you can see it's updated with the new changes that I have done. So it's actually, this is my first time I've been using CodeFresh. It was very smooth experience. Dan, you want to add anything to the pipeline? Or?
Yeah, I mean, sure.
So there are a few interesting things about this process, and we basically sat down last week and we're like, Ballerina, brand new language, let's plug it in, see what happens. And right off the bat, the question was, well, how do we actually build the Docker image appropriately? So one of the things with building Docker images, for anybody that's done this at scale, when you do a Docker build, you basically need access to the Docker daemon. And this creates security concerns when you're working on a shared environment. It means that you basically expose everything that's running on Docker to whatever that service is that's building. So with CodeFresh, the way that we work around that is we actually have a built-in build step that separates it out and runs it essentially isolated so it's not an issue. So if you're on a pro account with CodeFresh, you can actually have isolated nodes so you can have daemon access and it's fine because you've sort of opted into that. But CodeFresh by default isn't gonna do that. So what we needed to do here is we actually had to separate out the build step from the normal Ballerina build. And so what we basically did is set it up, and I think there was an option that you used that basically said, don't build this stuff. And by doing that, it generated the Docker file, it generated the YAML files.
It sets to false
Yeah.
so that it won't build the Docker image, but it will build the Docker file.
Yeah, so once that's built, the next step in the pipeline can take the Docker file that's been generated and then build the image, and then it can apply those Kubernetes those YAMLs and those kinds of things. One of the really interesting implications of Ballerina, it's one of the things that I've been thinking a lot about, and one of the reasons we wanted to do this meetup, is that it takes a lot of the headache out of configuration management when it comes to versioning. So what I mean by that is, if you go to Google, for example, every time you, and they use monorepo famously. So if you don't know this already, Google uses one repository for everything. Chrome, Android, Gmail, Google.com, YouTube, they're all in one giant repository. It's pretty crazy, but it allows them to use shared services really effectively. But when they go to make a change, there's all this configuration that has to be generated and dealt with, and they have to check that as code. So they have this tool that's called Sisyphus. It's called Sisyphus because if anybody knows Sisyphus, the Greek legend, he's the guy who has to push a rock up the hill, and the rock falls down the hill, and he has to push it back up the hill, and he's just stuck doing that forever. Sisyphus is in hell. But if you guys want to talk about Camus and philosophy afterwards, and the implication, I'd love to talk about that too. But they call it Sisyphus because every time you make a change, it goes through, generates configuration, does a commit, which triggers the next build, which triggers a new configuration change, which does a commit, and it does this over and over until it's generated all the configuration that it needs, then it can go to production. Now you can do, if you're not working with something like Ballerina, you can do that with CodeFresh. You can actually generate your configuration, you can check it in, and you have this sort of GitOps mentality of I can do a git revert and it will go back to a state that my configuration files were in, even though they were auto-generated. But with Ballerina, you basically say, configuration is kind of a runtime problem in essence. So when I build my application, I'll generate those. And that puts you in a really interesting position where you don't have to deal with versioning these things separately. They're automatically packed in. So that's one of the cool novel approaches of Ballerina. Now, like I said, with this pipeline, because it is on the shared account, we had to disable the build image. If it were a pro account, then we could allow that, and it's really a security standpoint is the thing that's preventing us. But the pipeline was very easy to create. We basically, I was mentioning to someone this earlier, every step in this pipeline actually runs as its own container. And so you can see there's this step here that says build Ballerina, and I pull in an image that I built that just has the Ballerina tooling installed on it. It's like from Ubuntu, curl, Ballerina, deb, this package, and that's it. And once I've done that, I can say, okay, run this container, and now we can just run the Ballerina command as normal as expected. And then the next step, each of these steps, now they're separate containers, right? They're all attached to a single pipeline volume. So once I generated those configuration files, they're available in subsequent steps for other containers to pick up and work with. And so here we have the build step, which you can see as a built-in step. I basically just say, hey, build this image. Here's where the Docker file is. Here's where the working directory is. Do your thing. And then we can then run those unit tests, again, using that Ballerina image. And then the deploy to Kubernetes is just a built-in step. So this is very simple, and it is a build, test, and deploy pipeline where we've got everything up and running. Now this works as of 4 days ago with Ballerina, because we basically just sat down in a room and we're like, what do we need to make this thing work? Well, I guess we just need to turn off the Docker build, and we need to, so it's very easy to get up and running. But it puts us in a place, it works with, any language, because it's really just about containers. That's kind of the first class citizen for CodeFresh. Any questions on that? No, okay. You wanna, is there a few more slides to finish up?
That's basically it, I guess. Yeah, I have a couple of slides on, Ballerina Con coming up. So we have our very first conference coming up. So we actually have a separate conference on WSO2, like WSO2 Con. We have been having it for like a long time, but this is our first Ballerina conference. So you can sign up. It's free passes available. This promo code, And it's not just about Ballerina, but about different technologies like how to build microservices resiliently, how to build transactional microservices, role of service measures, and serverless. So there are like generic topics, and also some, most topics will have some kind of a convergence with Ballerina, how you can build that with Ballerina, but this may be useful if you're interested in cloud native app development.
Awesome, thank you. Let's give him a round of applause. Thank you. Well, with that, our event comes to an end. I think we have probably about 15 minutes to hang out and chat and ask questions afterwards. Feel free to network some more. I'm happy to talk anything Kubernetes, Istio, CodeFresh, CI/CD, Camu, I'm sure you're happy to hang out and answer some questions about Ballerina as well. So thank you.